Bismillahirrahmanirrahim. My name is Mohammad Rahil Rashid and I am enrolled in Bachelor's in Civil Engineering program in ComStats University Islamabad WA campus. The topic of my final year project is effect of variation of polypropylene fibers content on mechanical properties of locally developed reactive powder concrete. My final year project is under the supervision of Raja Mohammad Tasaddiq, lecturer at Civil Engineering Department, ComStats University, Islamabad WA campus. My other final FIP group members are Adnan Hussain and Adyan Mahmood. So let's start with the introduction. Reactive powder concrete was developed in the early 1990s in a laboratory in France. World's first reactive powder concrete structure, the Sherbrooke Bridge in Canada, was erected in July 1997. Reactive powder concrete was nominated for 1999 NOVA Awards from the Construction Innovation Forum. RPC or reactive powder concrete is an high strength and high ductility cementitious composite with advanced mechanical and chemical properties. Its compressive strength is of the order 200 to 800 megapascal. Reactive powder concrete is considered to be the strongest and stiffest cement-based material. Reactive powder concrete is a kind of high ultra performance concrete with high strength, high tenacity and low porosity. Physical and mechanical and durability properties of RPC shows that RPC possesses better strength, both compressive and flexural, and lower permeability than other types of concrete. In order to increase the compressive strength of concrete even further, the only way is to remove the coarse aggregate. This philosophy has been employed in what is today known as reactive powder concrete. So basically there are no coarse aggregates in the reactive powder concrete, and it is a high strength concrete. The normal concrete strength is of the order 80 to 120 megapascal of compressive strength, but the reactive powder concrete's compressive strength is much higher, and it lies between 200 to 800 megapascals. And these values we have got from different researches and all of these kinds of analysis of structures. So basically reactive powder concrete is an emerging technology, and it is based on application of some good principles to achieve enhanced homogeneity, very good workability, high compaction, improved microstructure and high ductility. Also reactive powder concrete has a very dense microstructure, giving it an advantage of water cooling and durability characteristics. It could therefore be used for constructing industrial and nuclear wastage storage facilities where there is a chance of radiation leakage. So the objective of our final year project is to develop reactive powder concrete using local available materials, to investigate the effects of polypropylene fibers on mechanical properties of reactive powder concrete, investigate the improvement in strength of RPC by hybridization of polypropylene steel fibers in comparison to steel or other type of fibers alone, to produce economically cheaper reactive powder concrete with similar performance to that of the traditional RPC, elimination of coarse aggregates for enhancement of homogeneity in the structure. So the project socio-economic benefits on societies are on the society would be reactive powder concrete is basically a type of ultra high performance concrete. Improvement of microstructure, elimination of coarse aggregates, particle packing and toughness enhancement are the main principle of the RPC development. To achieve these principles, RPC is characterized by the inclusion of high cement content and pozzolanic materials that make, in the other hand, its production highly cost and non-environmental friendly. So also we are observing the sole effect of fibers which we are using polypropylene fibers in our project alongside with the steel, and the studies have shown that fibers they exhibit comparable strength to that of steel fibers alone, or even slightly higher when they are hybridized with steel fiber or other fibers uh, when they are fused together. Our project aims to develop a locally available, high strength and environment friendly reactive powder concrete by including materials that are easily available on local level, cheaper, and are recyclable or can be or are recyclable or recycled, just like the silica fume we are using, and it is a byproduct of electric furnaces. So these are the material composition of reactive powder concrete. It is basically constituted of cement, silica fumes, and quartz powder, polypropylene fibers, and steel fibers. And now we will move towards the methodology. So the first thing we will consider would be the mixed proportion of our FIP. So basically we have taken ordinary Portland cement. We have taken the quantities by weight percentage or by volume percentage. So ordinary Portland cement we have taken 1% by weight of total batch, and steel fibers we have taken 1.5% of the total volume of the calculated specimens, and polypropylene fibers, these all things are calculated by weight percentage or by volume percentage. The specimens we have now tested up till now are cylinders and cubes, and we have checked their maximum compressive strength, and the um, strength was very good in terms of the results we have generated from we have got from actually from the literature review. It is basically achievable for producing the conclusion we have drawn is that it is achievable for producing RPC mixtures containing availably local materials to obtain 150 megapascals compressive strength with the following mixture proportion by weight: cement 1%, fine sand 1%, silica fume 25% of volume, uh, water cementitious material ratio, cement ratio 0.30%, and steel fibers 1.5% by volume. So we have achieved the desired strength, which is much more than the structures made with ordinary concrete, which is in the daily life use. So these are some pictures of the specimens we have casted and we have tested, from where we have drawn the results. Thank you.